Hello friends, in this video I'm going to discuss some results related to Fibonacci sequence. For a Fibonacci sequence, Fn proved that summation Fk, k from 1 to n is equal to f of n plus 2 minus 1. This is our first result for a Fibonacci sequence. Fn is given to be a Fibonacci sequence. Okay, let us prove this result. For a Fibonacci sequence, we have, by definition, Fn is equal to Fn minus 1 plus Fn minus 2 for n greater than equal to 3, and F1 is equal to 1 and F2 is equal to 1. This is Fibonacci sequence. Recursion formula for Fibonacci sequence. Okay. Now, from this implies f of n minus 2 is equal to f of n minus f of n minus 1, n greater than or equal to 3. Now take n minus 2 is equal to k. That is, n is equal to k plus 2. If I take n minus 2 is equal to k, then n is equal to k plus 2. Now n is greater than or equal to 3. This implies k plus 2 is greater than or equal to 3, and which will give us k is greater than or equal to 1. Clear? Here we have Fn is equal to f of n minus 1 plus f of n minus 2. So I can write from this f of n minus 2 is equal to f of n minus f of n minus 1 for n greater than or equal to 3. Now we have taken n minus 2 is equal to k. This will give us n is equal to k plus 2. Now n is greater than or equal to 3 will imply k is greater than or equal to 1. Clear? Therefore, we have f of k is equal to f of n is k plus 2, f of k plus 2 minus f of k plus 1, where k is greater than or equal to 1. Substituting value of n, which is k plus 2, in this equation. Clear? Okay. Now we consider the summation. Now here we have, I will again write this equation. We have f of k is equal to f of k plus 2 minus f of k plus 1, where k is greater than or equal to 1. Okay. Now consider this sum fk, k running from 1 to n, is equal to f1 plus f2 up to fn. Now f1 from here, f1 will be f of 3 minus f of 2 from this equation. Same way f2 will be f of 4 minus f of 3 plus f3 will be f of 5 minus f of 4 up to fn will be f of n plus 2 minus f of n plus 1. Clear? Now this f3 will get cancelled out. Again f4 will get cancelled out, and we will be left with f of n plus 2 minus f of 2. This and this term will be left. Okay. And by definition we know f2 is equal to 1. Since f2 is equal to 1, it is defined as f1 and f2 are defined as 1. Therefore we have 1 here. Okay. Therefore summation fk is equal to f of n plus 2 minus 1, where k runs from 1 to n. Hence proved. Clear? Now second result, summation fk square, k running from 1 to n is equal to f of n into f of n plus 1. Next result is summation fk square, k from 1 to n is equal to f of n into f of n plus 1. Now we will prove this result by using principle of mathematical induction. We prove the result. We prove this result by using the principle of mathematical induction. Mathematical induction. Principle of mathematical induction means we will check if result holds for k is equal to 1, and if it is so, then we will assume the result for k is equal to n or m, and then we will prove the result for k is equal to n plus 1. Okay, this is principle of mathematical induction. Okay, now let us prove this result. Statement is summation fk square is equal to f of n into f of n plus 1 k from 1 to n. Okay, now for n is equal to 1. For n is equal to 1, left hand side is equal to f1 square, and by definition f1 is 1 square, that is 1, and right hand side is equal to f1 into f2, and by definition f1 is 1, f2 is 1, that is 1 into 1, that is 1. Therefore result is true for n is equal to 1. Okay, now assume the result for n is equal to m. For n is equal to m, we are assuming the result, that is summation f k square k from 1 to m is equal to f of m into f of m plus 1. Mark this is 1. We will prove the result. For n is equal to m plus 1. That is, we are now going to prove summation f k square k from 1 to m plus 1 is equal to f of m plus 1 and m plus 2. Clear? Now, this we have assumed. Now adding f m plus 1 f m plus 1 square to both sides of equation 1. Both sides of equation 1. Okay. This will give us summation fk square plus fm plus 1 square. Here k 1 to m is equal to f of m fm plus 1 plus fm plus 1 square. Clear? Now this left hand side is nothing but this is summation fk square k running from 1 to m plus 1. I can write like this, and this is equal to, taking fm plus 1 common, we have f of m plus 1. Clear? And by definition, this is nothing but m plus 2. fm plus 1 is equal to f of m plus 2. Okay? Hence proved. That was we have to prove. Clear? Proved. That means result holds for n is equal to m plus 1. Therefore, result is true for n is equal to m plus 1, and hence by principle of mathematical induction, result holds for all values of n. Result holds for all values of n. Clear? Now, third result, f of n plus 1 into f of n minus 1 is equal to, minus f n square is equal to minus 1 power n for n greater than or equal to 2. Okay, this is our third result, f of n plus 1 into f of n minus 1 minus f n square is equal to minus 1 power n for n greater than or equal to 2. Okay, again we will prove this result by using principle of mathematical induction. We prove the result by using principle of mathematical induction. Okay, and for this first we will check for here n is greater than or equal to 2. Okay, so we will check for n is equal to 2. Okay, for n is equal to 2, left hand side is equal to f3 into f1. Okay, minus f2 square. Now f3 is 2. Okay, f3 is f1 plus f2. 1 plus 1 2 into 1 minus 1 square. That is 2 minus 1, that is 1. And right hand side is equal to minus 1 power 2, that is 1. Therefore, result is true for n is equal to 2. Clear? Next, assume the result for n is equal to m. That is, this we have assumed now, f m plus 1 into f m minus 1 minus f m square is equal to minus 1 power m. Okay. Now, we will prove the result for n is equal to m plus 1. Okay. Now, we will prove the result. We will prove the result for n is equal to m plus 1. That is, we are now going to prove f of m plus 2 into f of m minus this is equal to minus 1 to the power m plus 1. Okay, that we have to prove now. This is to prove. Okay, now consider fm plus 2 into fm minus fm plus 1 square. Now, by definition, this can be written as f of m plus 1 plus fm, and this is into fm minus fm plus 1 square. This by definition. Clear? Now, this is again equal to f of m plus 1 into fm plus fm square minus fm plus 1 whole square. Now, this is fm plus 1 and I can take common. I can take fm plus 1 common from first and third term. This is fm minus fm plus 1. I can write like this, taking fm plus 1 common plus fm square. I can write like this. Clear? Now, fm plus 1 is equal to fm plus fm minus 1 by definition. Clear? This will imply f of m minus 1 is equal to f of m plus 1 minus fm. Okay. Therefore, from here we get this is equal to fm plus 1 and fm minus fm plus 1. This is minus fm minus 1. Clear? Plus fm square. That is, this is equal to minus fm plus 1 into fm minus 1 plus fm square. Clear? Taking minus outside, we have m minus 1 minus fm square. Okay. Now, this is nothing but, from here we have assume f of m plus 1, f of m plus 1 into fm minus 1 minus fm square is equal to minus 1 power m. So, I can write like this, minus 1 m, that is, this is minus 1 power m plus 1. Okay. Therefore, result is true for n is equal to m plus 1. Clear? Therefore, by principle of mathematical induction, therefore, I can say, therefore, by principle of mathematical induction, result holds for all n greater than or equal to 2. Clear? Now, fourth result, fn is equal to alpha n minus beta n divided by alpha minus beta, where alpha, beta are roots of the quadratic equation x square minus x minus 1 is equal to 0. This is our next result. We have to prove fn is equal to alpha power n minus beta power n divided by alpha minus beta, where alpha and beta are the roots of quadratic equation x square minus x minus 1. Okay, is equal to 0. Now, since alpha, beta are roots of the equation x square minus x minus 1 is equal to 0, this will give us alpha square is equal to alpha plus 1 and beta square is equal to beta plus 1. Alpha and beta are roots. Therefore, alpha and beta will satisfy this equation, and hence we have this. Okay. Now, again here also we are going to use principle of mathematical induction. We will use principle of mathematical induction. Okay. Now, for n is equal to 1, f1 is, left hand side is f1, which is 1 by definition, and right hand side is equal to alpha power 1 minus beta power 1 divided by alpha minus beta, that is 1. Therefore, result is true for n is equal to 1. Okay. Again, for n is equal to 2. For n is equal to 2, left hand side is equal to f2, which is again by definition is equal to 1, and right hand side is equal to alpha square minus beta square divided by alpha minus beta. Clear? Now, alpha square is equal to alpha plus 1 and beta square is equal to beta plus 1. So, I can replace alpha square and beta square by alpha plus 1 and beta plus 1. This is beta, sorry. And this will give us 1. 1 will get cancelled out. We are left with alpha minus beta in the numerator and denominator as well. Therefore, right hand side is equal to 1. Therefore, result is true. Result is true for n is equal to 2. Okay. Now, assume the result. Assume the result for m minus 1 and m for some m greater than or equal to 2. That is, now we are assuming the result for n is equal to m minus 1 and for n is equal to m. That is, f m minus 1 is equal to alpha m minus 1 minus beta power m minus 1 divided by alpha minus beta, and fm is equal to alpha power m minus beta power m divided by alpha minus beta. To prove, we will prove the result for n is equal to m plus 1. That is, we are now going to prove f of m plus 1 is equal to alpha power m plus 1 minus beta power m plus 1 divided by alpha minus beta. This we are now going to prove. Okay. Now consider f m plus 1, which by definition is equal to f of m plus f of m minus 1. Now substituting the values of fm plus fm minus 1 from here in this equation, we get this is equal to alpha power m minus beta power m divided by alpha minus beta plus alpha power m minus 1 minus beta power m minus 1 divided by alpha minus beta. Now this is equal to alpha m plus alpha m minus 1 minus beta power m minus beta power m minus 1 divided by alpha minus beta. Taking alpha m minus 1 common, we get alpha plus 1 here, and same way taking beta power m minus 1 common, we have beta plus 1 here divided by alpha minus beta. Now alpha plus 1 is alpha square and beta plus 1 is beta square, and this is equal to alpha m plus 1 minus beta m plus 1 divided by alpha minus beta. Okay, hence proved. Therefore, result is true for m plus 1, and therefore by principle of mathematical induction, result is true for all n. Clear? Hence proved. Now we come to next result. Prove that f1 plus f3 plus f5 up to f2n minus 1 is equal to f2n for all n. Okay. Next, we will prove this result. Okay. Now, we know by definition of Fibonacci sequence, we know fn is equal to fn minus 1 plus fn minus 2 for all n greater than or equal to 3. Okay. And from here, we can write f of n minus 1 is equal to f of n minus f of n minus 2. Clear? I can write like this. Now, this will give us f1 is equal to f2. Both are equal to 1. And from here, we have f3 is equal to f4 minus f2. f5 is equal to f6 minus f4. Okay. And same way, f of 2n minus 1 is equal to, from here, f of 2n minus 1 plus 1, from here, minus f of 2n minus 1 minus 2. Minus 1, sorry, here minus 1, minus 1, minus 2. Okay, minus 1 here. That means we have f of 2n minus 1 f of 2n minus 1 is equal to f of 2n minus f of 2n minus 2. Clear? Now adding above equalities, we get f1 plus f3 plus f5 up to f2n minus 1 is equal to f2 plus f4 minus f2 plus f6 minus f4 up to f of 2n minus f of 2n minus 2. This f2 will get cancelled out, f4 will get cancelled out, and we are left with f of 2n. Clear? Hence proved. Okay. Next we consider the result f2 plus f4 f6 up to f2n is equal to f2n plus 1 minus 1. Okay. Let us now prove this. We have f2 is equal to f1 is equal to 1. f4 is equal to f5 minus f3. Here we are taking even terms 2, 4, 6, 2n on left hand side. Okay. f2, f4, f6 is f7 minus f5 and f2n will be f2n plus 1 minus f2n minus 1 and f2n minus 2 will be f2n minus 1 minus f2n minus 3. Okay. Now adding these equalities we get adding above equalities we get f2 plus f4 plus f6 up to f2n is equal to f1 plus f5 minus f3 plus f7 minus f5 up to f2n minus 1 minus f2n minus 3 plus f2n plus 1 minus f2n minus 1. This f5 will get cancelled out. f2n minus 1 will get cancelled out and we are left here with f1 minus f3 plus f2n plus 1. Now this is f1 is 1, f3 is 2. So we have this 2n plus 1 and this is f of 2n plus 1 minus 1. Clear? Hence proved f2n plus 1 minus 1. Clear? Okay, now that's it for this video. If you have any queries or any suggestions, please write to me in comment box. Thank you.